All right, so quadratic formula. What is it? Yeah. X equals negative b. I'm going to clean that. Hey, is this yours? It is. Thank you. All right, thank you. All right. So there's our stuff. A, B, and C are in the problem where they're at. A is always in front of x squared. B is always in front of x. C is the constant on the end. Remember, it has to be equal to what? 0. If it's not equal to 0, we got to get it there so that we can do quadratic formula. And based on the discriminant, it is the b squared minus 4ac part. It's the part underneath the square root. The discriminant discriminates what kind of answers we're going to have. Okay? If that discriminant is less than 0, then we'll have complex solutions. What kind of answers does that? What's that mean? Complex. What's it got in it? I did a whole section on it. Complex numbers. What do they have in them? The I. Coming from a square root of what kind of number? Negative. Discriminant less than 0. That's a negative number. If the number underneath the radical ends up being negative, we're going to have complex solutions. 2 of them. Complex solutions. If that discriminant, b squared minus 4ac, is equal to 0, we'll have 1 real solution. We'll write 2 there. 2 complex solutions. If b squared minus 4ac is not equal to, but greater than 0, we'll have 2 real solutions. Okay. Now, when we get into graphing, which is the next step when we go to quadratics, we'll do a lot of stuff with graphing them and various forms of their equations for the graph. What we'll see is that when we graph a quadratic, the discriminant being 0 or a positive number is going to show up on the graph. It'll be where it crosses the x-axis. If the discriminant is negative, then it won't cross the x-axis. We'll see that when we get there. You're kind of trying to foreshadow what you'll see later on. But the discriminant is important. So that's one of the things I want to ask you. What's the discriminant of this quadratic? What does it tell us about the answers? So you would tell me what the number is, and then does that number indicate 2 complex solutions, 1 real solution, or 2 real solutions? And then probably find the solutions from there. Okay, so let's look at some examples of actually doing the quadratic formula using that discriminant and all that stuff. So we'll do a few examples of this. So solve the problem. Example A, nice easy one. X squared plus 3x minus 2 is equal to 0. Is that ready for the quadratic formula? Yes, because it is equal to what? 0. Okay. So one of the things I want to try to get you in the habit of doing is to find the discriminant first. All right. So remember, that's the b squared minus 4ac part. So b is 3, a is 1, c is negative 2. Find that part first so that you know what kind of answers you're looking for. So that'd be 9 plus 8 to be what? 17? What kind of answers should I have? 2 real ones. Okay, that's a positive number, so we're not going to have an imaginary part to that. So we got 2 real solutions. Okay, maybe make a note of that. 2 real solutions. That's important to know. It becomes even more important when we start doing graphs later on. Okay. All right. So let's work that out. So x equals negative b plus or minus radical. Well, I've already done that part. That's 17 over 2 times a. simplify as much as possible. -3 plus or minus. Square root of 17. Does 17 break down with the square root? No, it doesn't. So we're just going to leave it square root of 17, all divided by 2. Now, what I want you to kind of be able to do, this is the exact solutions. That's two different solutions. But also, especially when we start going to do graphs, we're going to need to be able to plot these on a coordinate plane. So we're going to need the decimal equivalent for those. So we're going to do a decimal approximation for that as well. So -3 plus the square root of 17, all divided by 2, and then -3 minus the square root of 17, all divided by 2. And the only time you need to do a decimal approximation is when you have real solutions. If you've got complex solutions, there's no point in doing the decimal approximation because it's not going to show up on the graph. Okay, so let's get the decimal approximations for those. I'll open my calculator here. Work that out. So -3 plus the square root of 17, and then divide that answer by 2. And how you do that in your calculator is totally up to you. I'm going to do -3 plus the square root of 17. To get the square root with the graphing calculator, you hit the second and then square root, or then the x squared button. Need a calculator. You can borrow. And then I always just do it separate. It's about the same number of keystrokes whether you put parentheses or enter or not. And then divide that answer by 2. Because that was what's on the bottom. So I'm going to round it to 2 decimal places because that's about all we can guesstimate anyway when we go to graph it later on. So 2 decimal places is plenty for me. So that would be 0.56, and then do the minus, -3 minus the square root. So second x squared 17, enter, and then divide that by 2. It'd be somewhere around 3.5. Yeah, 3.56. -3.56. So exact answers, and if they're real, get decimal approximations for those two. Okay. Exact answers are the ones with the square root still in it, simplified, of course, and then decimal approximations if they're real solutions. Okay. How do we know that we'll have real solutions? The discriminant will be what? Or equal to 0. Okay. The discriminant is positive or equal to 0, then we're going to have real solutions. If it's negative, we're going to have complex, and we don't have to worry about decimal stuff with that. Okay. Let's look at another one. Example B. X squared is equal to 6x minus 4. Is that ready to work with? No, it's got to be equal to what? 0. Which direction do you want to move in? Yeah, that's a good idea. Why would you want to keep the x squared positive? It does help with what? Does anybody remember? He's right. I did tell you that. Not often people remember what I say, so let me step back there. Just a freshman, they don't remember anything you say. It's for factoring is when the x squared, if you got it positive, it makes factoring a lot easier. We're not factoring here, but I still like the idea of leaving the squared part positive, just out of habit. Because if factoring is something you need to do, having that x squared be positive is a good idea. So I like that. So I'm gonna move those in one step. So there's my equal to 0. So I got x squared minus 6x plus 4. So I moved everything over to the left side so that I could have it equal to 0. The good thing about quadratic formula is it doesn't matter. If you move the x squared over to the other side and had negative x squared, a is -1. And the formula works the same. You get the same answers. You just got to simplify a little bit more when that's happening, or you got to look for ways to simplify. So it doesn't matter which side you move stuff to, but I like moving it this way. So let's get the discriminant, and I'll just abbreviate the disk for this. What's the formula for the discriminant? All right, so B is -6. 4 times A is how much? 1. C is positive or -4? Positive 4. Be careful on your signs because you miss one sign with this, it can change the answers. Okay. Be careful if you're going to evaluate this. I usually don't use a calculator, but if you are going to type that into your calculator, when you square -6, what kind of answer should you get? Positive. If you're going to type that into the calculator, be sure to use parentheses with the squaring part, because if you don't, it's going to give you the wrong answer. It's going to work it exactly how you typed it, order of operation style. So I'm going to get 20 for the discriminant, which tells us that we have what kind of answers? 2 real solutions. All right. Let's work those out. X equals -b plus or minus radical b squared minus 4ac divided by 2a. Okay. Now, can we simplify this? Square root of 20? It is. It's an easy one to remember. Most of us have heard it before. Can the square root of 20 simplify? As what? 2 square root of 5. So we end up with 6 plus or minus 2 radical 5. All that divided by 2. And will that simplify? How do we simplify something like that? So you're dividing these 3 numbers by what they're all divisible by. So that'd be 3 plus or minus square root of 5. Technically, it's a 1. And it's over 1 now because everything was divisible by 2. So we get, something pretty easy to deal with. There's our exact answers. Let's get the decimal approximations for that. Not already plus. Let's do the minus one. So 3 plus the square root of 5. Whoops. 3 plus the square root. Let's try it again. 3 plus the square root of 5. Enter. 5.24. Got to learn to round if you don't know how. So there's one of our answers. And then 3 minus the square root. So 3 minus the square root of 5. 0.76. Not too difficult there. Important. I'm going to be picky. If you don't simplify the exact answer, I'm going to count something off of that. You're supposed to do that. It's part of mathematics, simplifying. So we need to make sure we do that. All right. Questions about example B? Not a bad one. Got a couple of them with real solutions. Let's see what this next one does. Example C. Let's say we had negative x squared plus 4x is equal to 5. Started this one out. Not too great, but we can fix it if we need to. Is it ready to go? No. What do we got to do? Got to get it equal to 0. So you got a couple of options of how to do that. One way is one step. The other way is one step. It really doesn't matter which way you do that.
Yeah, but you said that x squared needs to be positive.
We like it to be positive. It does seem to help with sign changes and all that stuff. So that's the way I would do this. If you do that by moving the 5, we better get the same answers. If we don't get the same answers, one of us did something wrong. Okay? So I'm going to move it this way. Because Trevor is obviously someone who's going to hold me to what I said, that the x squared has got to be positive. If it's not, we make it positive. So here we get 0 on the left side now, and x squared minus 4x plus 5 on the right side, which is absolutely fine. Sure. Brandon, could you do that for us? Thank you. If you perchance, maybe you forgot that rule, not that it's a rule, and you worked your problem and got it to look like this. How can you change the sign of the x squared?
Divide all my negative numbers.
Absolutely. And you get the same thing here. Okay, so a couple of different ways to work that, but it works okay. All right, so let's get the discriminant. Negative b plus or minus b squared minus 4ac divided by 2a. All right, so the discriminant. We have negative 4 squared, which is 16, minus 20. 16 minus 20 is negative 4, right? Which is a negative number. So that means we're going to have what kind of answers? Complex. So that means we don't have to do the decimal stuff at the end. Okay, we just need to get our answers in complex number form. Okay, so x equals negative b plus or minus radical b squared minus 4c divided by 2a. And then, so that's 4 plus or minus. What's the square root of negative 4? 2i. Good job. Over 2. And then we think, oh, it's complex number, so we got to write it in complex number form, right? So we split them apart. 4 over 2 plus or minus 2 over 2i. And simplify those. 2 plus or minus I. Two answers for a quadratic equation. That should make sense. Complex solutions at that. Had you worked it with a being negative 1 and b being a positive 4, you end up with the same answer because you end up with 2 times. You have a negative 4 plus or minus 2i. The discriminant doesn't change with the signs there. Over negative 2, and the negatives cancel each other out. It ends up the same answers. If you worked it the other way, it doesn't change anything. All right. Easy enough. Next problem. Let's go a little bit more difficult. Maybe something a little fancier. 7x minus 5x squared minus 4 is equal to 2x plus 3. Let's just rip the Band-Aid off instead of just kind of easing into it. Let's just go ahead and do it. So, a lot more going on in that problem. What do we need to do? All right, so how do we do that? Okay, so moving the 2x over, that's a good idea. What else? Moving the 3x over, or the 3 over, not the 3x, but 3. So if we do that, we got to make sure that we put it with their like terms. And these cancel out, and there's it equal to 0. And Trevor's not going to like us on this one because we didn't get the sign the right way, but we know how to fix that, right? Because that's negative 5x squared plus 5x minus 7, right? Is that what you guys got? Maybe you didn't get it in that order. Why do I want it in that order?
Because it's descending order by the variable.
Very good. Descending order by the powers of x. And so that gets us a, b, and c. If you don't like a being negative 5, how can you make it positive 5? Put a negative 1 through either by multiplication or division. Doesn't matter which way. I'm going to leave it negative just to work in one with it like that, just in case Trevor can just deal with it. If you want to change it, we should get the same answer, so it should check. Okay, good. So good. That eases my mind that I don't have to worry about pleasing you all. All right, so let's get the discriminant. What's the discriminant? 5 squared minus 4 times negative 5 times, negative 7. That's 25 minus a big number here. 28 times 5 would be 140. Should be a negative 115, right? So what kind of answers we're going to have? Complex. Got a negative discriminant. It's going to give us complex solutions. X equals negative b plus or minus radical b squared minus 4ac is negative 115 divided by 2a. And then simplify that. All right, so does 115 break down? Okay, 5 goes into it, I know. How many times? 23. But 23 is prime. So no further do we break down there. So what does come out of the radical, though? An I. Then we have a 10 in the front. Now, I would normally be okay with this as the solution. But I want to just show you how different tests, like your end of course tests, they're probably going to be a little bit different. ACT is probably going to be a little bit different in how they accept answers and things. And, you know, if we'd end up with a multiple choice type situation for this problem, we might want to be able to simplify in the complex form. Because remember, the complex form is A plus BI. So, you know, you gotta separate them. That's the standard form of that. So you could simplify one of the fractions there to be negative 1/2 plus or minus, technically written 1 square root of 115 over 10 with an I out beside it. I would take that on the quiz. That's fine with me. You could stop there because it doesn't simplify both pieces. But understand that this and that are the same thing. And this is probably more of like an ACT type answer, the way they would write it, than the way I would accept an answer. Both of those are acceptable, though. They're equivalent solutions. All right. Let's do just a few more. Oh, let's just do one more. I think that's enough. This is not anything. It's not rocket science, even though it kind of leads to rocket science. Anybody gone to see Hidden Figures yet? Maybe me and my wife are the only nerds that go to see the math movie for a day, but it was pretty awesome. Well, Hidden Figures is about these ladies in NASA that they were instrumental in the early beginnings of the space program when we were racing with Russia, racing with Russia to get into space and get to the moon. They were instrumental in getting us there by calculating all the things. It's a really good movie. I was impressed with it. It's a good story. It's based off of true stories. Everything that happens. That's the one she wanted to see. That's the one you take her to. You don't pick another one if she picks one. You'll learn that one. All right. It had math in it. Technically, every movie has math in it. All right. We have this problem. It's quadratic, so we know we're going to solve it using some method. We're using
Tori holds reports to office.
Quadratic Formula today. That's our goal. So we need to get it equal to what? 0. So this one, the A is already positive there, so I'm just going to move everything to the left. Nobody ever said anything about buying somebody a fake ring. I wouldn't do that. I'm not a very smart man, but I am a pretty smart. I'm smarter than that. All right. So we got this going on. One thing that can help your life be a little easier is you kind of look for a common factor there, and if everything was divisible by a certain number, you divide by it at the beginning. could make the numbers smaller, make less simplifying at the end. This one doesn't do that, but just want to mention that so that you know that you can do that. It is legal to do that, but this one doesn't work that way. So discriminant, negative b plus or minus radical. This is the part we want. We want b squared minus 4 times a times c. And then let's figure that out. So that's 144, and then 9 times 36, or 9 times 16 is 90 plus 36. Did I do that right? Yeah. It's 100 and 9 times 4 is 36 times 4. 36 times 4 is 144. I know that. So the discriminant is how much? Which means what? One real solution. So one real solution. And that makes the square root part pretty easy, because now you go x equals negative b plus or minus the square root of the discriminant over 2 times a. And we can reduce that to be 3 over 2. Its decimal approximation, or actually we'll get a terminating on this, will be 1.5 out of that. We only have one solution. What that does is when we start talking about the graphs of these, what's happening with this graph is over here at 1.5, so there's 1 and 2. 1.5 is right there. The graph just touches the x-axis there at 1.5. It doesn't go through it. It just bounces off of it. That's what happens when you have one real solution instead of two. If you've got two, it's going to go through the x-axis and touch in two places. If you only have one, it bounces off of it. Is what happens there. Yeah, and then it's a quadratic, so it's going to make the parabola shape anyway. Out of that. All right. I'm trying to find something else to do here. That's all there is. So we're done. All right. So here's the skinny for today. 296, 3 through 29, odd. 41 through 47, odd. The kind of schedule for the rest of the week. Let me stop the recording here so I can tell you